Here is an example that we want to find the mean, median, and mode of, but we want to do it by hand just to make sure we understand how to do this. So what we're looking at is a group of Brigham Young University students who collected data on the speed of vehicles traveling through a construction zone on a highway. And they recorded 14 speeds randomly. They selected 14 random vehicles, and their speeds are given below. So we can see the speeds of all 14 vehicles here. What I'd like to do is I want to compute the mean, the median, and the mode for this set of 14 data points. Now, I'd like to do this by hand, and I can always check my work using StatCrunch. But to do it by hand, what I first need to be able to do is order the list from smallest to largest. Remember, that's how we're going to handle a list when I want to find the median. And since I'm going to have to find the median along with the mean and the mode, I might as well order the list to start with. Then I'm going to take the list, add up all of those numbers, and divide by 14 because that's how many total numbers were in the list. After I find the mean, I'm going to look towards the median. So let's look at our answers here. I'll give you a moment to pause the video to calculate the mean, median, and mode on your own, and then we'll look at our answers together. So here we have the solution. And in red, you can see that I ordered the data set from smallest to largest, and that's how I need to handle it to find the median. This is a sample set, and so therefore when I find the mean, I'm going to use X bar for my symbol. When we added all the numbers up, we got 450, divided it by the total of 14 speeds, and we can see that the average speed is 32.1 miles per hour. To find the median, remember that we had 14 points here, or 14 values in this set. So that is an even numbered set. And if I want to consider the median would be the halfway point in my set. When my set is even, you would consider, say, 7 speeds down one half of it, 7 speeds down the other half of it. So if I were to fold the list in half, I would have 7 speeds on one half, 7 speeds on the other. And then right in the middle of that fold, in between 32 and 33, is going to be the median. So when you have an even numbered set, we're going to add those two numbers together, 32 plus 33, divide by 2 to find the halfway between them, and we can see that it's 32.5. And then the mode, we've already discussed that a mode would be the value that's occurring most often. And so you can see here that we have the number 40 that occurs twice. And when you order a data set, you'll be able to quickly identify things that occur more than once because they'll be falling next to each other since you've ordered it. One other thing I would like to point out here is sometimes when you are looking at a data set by hand, if you want to quickly find the median, you could take the data set you ordered and then just mark off from both ends incrementally one number from each side. And as you keep doing that, you will eventually get to the middle of the data set. Now, if you get to the middle of our data set and you have 2 numbers left over, those are the 2 numbers that you would then add together and divide by 2. In an odd data set, as soon as I was marking numbers off incrementally and getting to the middle, there wouldn't be 2 numbers left here. There would be only 1 number left in the middle of the data set, and that would be your median. So by hand, if we wanted to do it, this is what that would look like. Now notice here also that the mean is 32.1, the median is 32.5, and those 2 numbers are relatively close to each other. So they're almost the same value. And so we would get a sense of what a histogram would look like for this here. So here at the top of your screen, I've gone ahead and graphed the histogram of this data set, and you'll notice that this histogram is a bell-shaped histogram. And one of the characteristics of a bell-shaped histogram is that it is symmetric. So we find then that when I have a symmetric distribution, say a bell-shaped uniform, or even bimodal shaped histogram, all three of those would indicate that your mean and your median were relatively close to each other. And you can see that I have my mean and my median line graphed here on my histogram, and they're almost touching, they're almost laid on top of each other. So when we think about a histogram that is symmetric, we already get an idea then for the sense of what the relationship is between our mean and our median.